We're solving problem 20 from the 2024 F equals MA exam. 4 massless rigid rods are connected into a quadrilateral by 4 hinges. The hinges have mass M and allow the rods to freely rotate. A spring of spring constant K is connected across each of the diagonals so that the springs are at their elapsed lengths when the rods form a square. Assume the strings do not interfere with each other. If the square is slightly compressed along one of its diagonals, its shape will oscillate over time. What is the period of these oscillations? And here's what happens if it does oscillate. Suppose we just push these top things together. These two horizontals will bulge out, each displacing a distance of x, x units. So we can say that our k is equal to, well, what is this? 2 times 1/2 mx now. And this is just the form of our k here, our spring. Now for u, our u, capital letter U, this is 4 times, or no, it's still 2. 2 times 1/2 k times 2 of these, and then 2x squared. So we have it in this form. Now, we know that the sum of k plus u is equal to, well, we want to sum these two together and then equate it to 0, because that equals to E, or energy. So 0, we can say, is equal to, well, this is just 2 times 1/2. I'm just going to write it in this form right now. And then you sum this one to 1/2 k and then 2x squared. When we simplify this, we get that this is 0 equals 2m, and then there's going to be a 2 times our x values here. Like that, and then you sum this. This is going to be 2 times, well, there's going to be 4 of this, 4 times k, and then these x values. So we have these, and this 4 coefficient can just translate out here, so this becomes 4 times that, and this 2 can also go outside, so 0 essentially is 4 times m times these x's. And then this is, because there's another 2 incorporated here, this coefficient is 8. So 8 times k x's. So we now have it in this form. Well, what we can first do is just factor out it. If we factor this out, this is just 4. This equation becomes this form. Right? 8k times x equals 0. If this cancels out, we can cancel the 4's, and this becomes a 2. So our equation just becomes this. Yeah. And this is pretty important here, as what we have achieved, we want to solve for this right here, the x. So that's negative 2k over m times our x. Don't forget that. And, well, this is actually pretty important because it helps us with this problem. So if this is true, we also know that this can also be equated to negative omega squared times x. Therefore, omega is equal to the square root of 2k over m. And there we have it. This is unfortunately not our answer, but it is really close in finding the period of these oscillations. Since we know that these oscillations occur in the form of 2 pi over omega, simply substituting omega into this equation, our answer becomes 2 pi times the square root of 2k over m. But since it's the denominator, these are reversed. So this is m over 2k, which is our answer. So they become reversed. So our answer would be 2 pi times m over 2k, and take the square root of that fraction. So that is our answer for this problem.